One of the things I like to collect are things that seem impossible, but they're staring you in the face, so they must be real. One example of something that seems impossible is square gears. But these work just fine. Likewise, elliptical gears seem impossible, but these too work just fine. One can understand how both the elliptical gears and the square gears work by noticing that you always have, at an extreme, the longest radius paired up with the shortest radius and all the possibilities in between. Another example of something that looks impossible is this nail in the wood. I first encountered the phenomenon in a woodworking shop where I saw something about this size in one of the display cabinets. I asked how it was made and they told me, so I made one, but I thought it would be more impressive if one made it out of a 2x4. So I tried to make it with the 2x4, but I could not get it to work. I eventually figured out that the problem was that in the case of a 2x4, the wood was not soft enough. And when I switched over to soft pine as the wood, then everything worked fine. So the way one makes this is you cut the notches out of soft pine, and then the part that almost nobody knows is that if you put the wood in steam for a couple hours, it then gets very soft, so that if you put a clamp on this, you can actually compress it about halfway. Just like with a wet sponge, if you put something heavy on it, it will compress, and if you leave the heavy weight on it until the sponge dries, it will stay compressed when you take the sponge off. Likewise here, if you leave the clamp on until it dries and cools, then when you take the clamp off, it stays compressed. You can then get the drill bit in to drill the holes. You can slide the nail in. Next to last thing you do is you put the whole thing back in steam. This pops up to about 90% of where it was in the first place, and you then hide your tracks by sending all the other ones down. This is an example of what happened with a real 2x4. The wood was harder. You can see how much this got compressed, but it also tipped over, and I decided to stop working on this particular one because if I kept going, eventually this would have a line here and everybody would think that had something to do with the process, even though it doesn't. Another example of using steam and wood is this cube, which is made out of oak and has a solid round stainless steel ball inside. One makes this the same way. You put the wood, you drill the holes in the wood, you put it in steam, and then you force the ball through. It's an illusion partly because the ball looks a lot bigger than the holes, but they're actually not that much different in diameter. The only thing you have to do is when you force the ball through is to brace the wood, because the ball tends to split the wood when you push it through if you don't brace it. Another example of something that seems impossible is this dovetail setup. It looks like it would be impossible to assemble this, but that takes advantage of people overlooking the obvious. And the obvious is seen in this puzzle, because you can simply slide it apart. It's the way the two pieces of wood are put together that is so misleading. One also sees the result of using steam in bending wood in kitchen chairs, where the back is made out of a bent piece of wood. Those are made by taking a straight piece of wood, steaming it, putting it in a form to impose a shape on it, and then letting it cool and dry in the form. Wooden sailboats are also made that way. The planks along the side are steamed before they're assembled. They're bent together at the bow and then screwed together so they retain that shape. That's how they bend them.